Hi and welcome. In this session, we'll try to get the conceptual understanding of car engines. Hopefully, by the end, you'll be able to identify what an engine was built to do. Engines are energy converters with trade-offs. We shall cover such ideas as mapping any engine with the four systems model, inferring purpose from build choices, and more. Engines turn chemical energy into motion. Fuel plus oxygen burns, gases expand, pistons move, the crank turns, the wheels rotate. If an engine won't run, one of four essentials is missing: air, fuel, spark, or compression. Every engine balances power, efficiency, durability, and cost. There's no free lunch. A track car tunes for high RPM power, a work truck for low-end torque and longevity, and a commuter for efficiency. The parts reveal the priorities. We'll use a simple mental map: air, the breath; fuel, the diet; ignition, the spark; mechanical core, the muscles and bones. Change one, and the others feel it. This interdependence is why good diagnosis is systematic. Follow the air path: filter, ducts, throttle, manifold, and, if equipped, turbo or supercharger. Big intakes and big compressors shout airflow, and therefore power potential. Quick checks: clogged filters, cracked hoses, sticky throttles. Older engines mix with carburetors. Modern ones use injectors controlled by an ECU. The plumbing, pump, lines, filter must deliver clean fuel at the right pressure. Performance builds use high-flow injectors or multi-barrel carbs. Quick checks: fuel level, pump prime, pressure, injector pulse. Spark plugs light the mixture, powered by coils and timed by a distributor or the ECU. High compression or boosted engines demand precise timing to avoid knock. Quick checks: spark at each plug, coil health, timing reference marks. Inside the block: pistons, rods, and crank turn pressure into rotation. The cam and valve train time the breaths. Materials matter. Aluminum is light and cools fast. Iron is heavy but tough. Bore and stroke tell a story. Long stroke favors torque. Big bore, short stroke favors high revs. Start with the silhouette. Cylinder count and layout: inline, V, or flat. Hint at smoothness, packaging, and center of gravity. Find displacement markings. Note fuel delivery, carb or FE, and look for forced induction. Check block and head materials. Each clue narrows the mission profile. Workhorse: longer stroke, conservative cams, iron block, modest redline, built to pull and last. Sport: short stroke, big valves, aggressive cams, often boosted, built to breathe at high RPM. Economy: small displacement, careful timing and fueling, lightweight construction, built to sip fuel. When it misbehaves, go AFSC. Air: is it breathing? Filter clear, no leaks, throttle moves? Fuel: is pressure right and delivery clean? Spark: do all plugs fire at the right time? Compression: do the cylinders seal? Air plus fuel plus spark plus compression equals runs. If not, one is missing. Start easy, cheap, fast. Listen for vacuum leaks, smell for rich or lean, watch for smoke color. Tools that pay for themselves: OBD2 scanner, fuel pressure gauge, spark tester, compression tester, and a basic multimeter. Change one variable at a time. Safety first: gloves and eyewear, beware hot parts and spinning belts. Disconnect the battery when appropriate. Minimum kit: OBD2 scanner, multimeter, test light, torque wrench. Nice to have: bore scope, vacuum gauge, timing light. In 5 minutes, identify cylinder layout and displacement, note induction, snap photos of intake, fuel rail, and coils, then state the engine's likely purpose and 2 trade-offs you observe. Practicing this builds fast intuition. Displacement is total cylinder volume. Compression ratio compares cylinder volumes, affecting efficiency and knock resistance. Bore and stroke define cylinder diameter and piston travel. AFR is air-fuel ratio. The ECU is the brain. Manifolds are the lungs. Timing is the choreography. Use the 4 systems as your map. Let the build choices tell you the mission. Diagnose with AFSC, starting with simple checks. Look, listen, measure, then decide. This approach scales from lawnmowers to Le Mans. Thank you for joining. Hope your understanding of engines improved, as did mine from doing this project.